Hi, my name is Venkanna Kota. Today I want to discuss of a rectifier. Rectifier. Here, the main definition of rectifier is that which converts AC signal or AC voltage into DC or pulsating DC signal. It is not an exact DC signal. It is pulsating DC signal. So, rectifier is also known as which converts bipolar signal bipolar signal into unipolar signal. So here basically rectifiers are two types. These are half wave rectifier and full wave rectifier. Now I want to discuss here half wave rectifier. Half wave rectifier. So what is half wave rectifier? Here half wave rectifier means this is if it is AC signal. If it is AC signal, so which converts only half of the portion. So this is input signal. So this is the output signal. In this output signal, so which converts only half of the positive portion, negative portion. Coming to the point of positive portion, negative portion, this is input AC signal. So input signal, the output of the amplifier rectifier is that only positive portion only transfer to the output. During the negative portion, the output is 0. So similarly, during the positive portion, the output is same as the input. So this is the output of the half-wave rectifier. Half-wave rectifier. So now I want to discuss the circuit diagram of the half-wave rectifier. So first of all, in the circuit diagram of half-wave rectifier, so this is a transformer. The indication transformer, and which consists of diode, PN junction diode, and this is here load RL resistor is connected. So we have to take the output across the load resistor RL. Here we have to take the output across the RL. So this is input AC signal. So this is diode D. So this is transformer. So here input AC signal. AC signal means the 230 volts. 230 volts AC signal is connected to the transformer which consists of primary winding, secondary winding. The lines indication the mutual connection between primary winding and secondary winding. So this is the symbol of transformer. So here basically in the transformer two types are there: step down transformer, step up transformer. Step down transformer means the high voltage which can be converted into low voltage. That transformer is known as step down transformer. And step up transformer. Step up transformer means which converts low voltage into high voltage. High voltage AC signal. That is known as step up transformer. So here in the half-wave rectifier we need only step down transformer. Why? Because for the operation of electronic circuits which requires only low voltage, 7 voltage or 12 voltage or 15 voltage. So that's why 230 volts which converts into low voltage by using only step down transformer. Transformer which converts high voltage into low voltage only. Transformer input AC signal and output is also AC signal. It is not a DC. Transformer input AC signal and transformer output is also AC signal. So here low voltage AC signal which is given as input to the diode. So this is basically here it is known as here VI input is given, that is low voltage AC signal to the PN junction diode. Capital D indicates PN junction diode which can be accessed on and off switch. Okay. During the forward bias the diode is accessed on switch. During the reverse bias the diode is accessed off switch. So here then the output of the diode current directly flowing to the load resistor. So we have to take the output across the load resistor. So here input, this is the input AC signal. First we have to apply the positive portion to the PN junction diode. During the positive portion, so positive, when we are applying positive to the diode, so this is forward bias. Then the diode access on switch. This is looking like switch, then this is on switch. Then what will happen? The input current directly passes to the load resistor and through the diode switch. Then the output voltage across the load resistor must be equal to the input. That is V0 is equal to VI. When D is on. So that's why here the output is same as, this is the output is same as the input. And during the negative portion, and that means when negative signal is applied to the diode, here the negative is applied. What will happen? The diode access off switch. Why? Because this is the reverse bias. In reverse bias condition, the diode access off switch. Then the input current does not pass it to the load resistor. Why? Because here no connection is there. So that's why V0 output is equal to 0. So V0 is equal to 0 when D, the diode is off. Diode is off. So this is the basic operation. of a rectifier. So similarly, the continuation, and during the positive portion, the diode access on switch, then the input current directly passes to the load resistor, and then the output across the load resistor must be equal to the input Vi. So this is continuous till the end of the input signal. So this is the output signal. So here, what is this? From this diagrams, this is input is bipolar, positive, negative, two polarity signals. So which converts into unipolar signal, unipolar signal only. And rectifier is also known as, which converts bipolar signal into unipolar signal. So this is the basic operation of a rectifier. So here let us consider Vi is equal to Vin is the sine wave. That's why input Vi is equal to sine omega t. Sine omega t. Why? Because here sine omega t indicates input is the sine wave. Input is sine wave. Input sine wave indicated like this. Letter Vi is equal to sine omega t. Vi is equal to sine omega t. Okay. So this is the basic operation and the circuit description of the rectifier. Then we have to see the analysis of the rectifier.